Hi, I'm John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, please do consider subscribing. On this particular video, we're going to talk about how to solve quadratic inequalities using an algebraic method. Let's start. When we solve quadratic inequalities using the algebraic approach, we're making use of this algebraic principle that the product of two terms being positive, this is actually non-negative, greater than or equal to 0 should be interpreted as non-negative. But when the product of two terms are positive, we know that there are two cases. Case 1 would be when A is positive and B is also positive. And the case 2 would be something like A is negative and B is also negative. So when A times B is positive, whenever A times B is positive, both those two terms, okay, both of those two terms must have the same sign. Both A and B must be positive, or, this is an or case, or both A and B must be negative. That's the algebraic principle when the product of two terms is positive or non-negative, as we say. And when A times B is negative, when the product of the two terms is negative, then the conditions are when A is positive or greater than or equal to 0, the second term B must be negative or less than or equal to 0. They both must have different signs. So this is one case. So we'll say or. The second case could be when A is less than or equal to 0 or negative, the other term, which is B, must be positive. So those are the two cases we have when the product of two terms are negative. Both must be of opposite signs, as opposed to when the product of two terms being positive or non-negative, both those two terms must be of the same sign. Both must be positive or both must be negative. So those are the two properties we need to keep in mind when we solve quadratic inequalities. Let's take an example to illustrate this. Okay, this is an algebraic method. The first thing I would do when I see a question like this is first I'll arrange it in a way that I've got all the terms on one side of the inequality. Okay, so the first thing I'll do is, let me just write it like this first. X squared is greater than or equal to 10 minus 3x. I've not collected all the terms as yet. I've just written it with the same inequality sign. This is still x squared is greater than or equal to. So here again, I have x squared is greater than or equal to 10 minus 3x. I've just written it the other way around, okay? Now I'm going to collect all the terms on one side of the inequality. I'm going to write it as x squared plus 3x minus a 10 is going to be greater than or equal to 0. So this is an example where we have greater than or equal to 0, okay? So let's first factorize it. That's the first thing to do in both the techniques, the algebraic technique and in the graphical technique. So for those of you who haven't seen my video on the graphical technique to solve quadratic inequalities, I'm going to link that video in the description box below. The first thing to do is to factor even in that graphical technique. So I'm just going to factor this quadratic and say, okay, what should it be such that it's going to be greater than or equal to 0? All right, so we've got a negative sign there. So it must be x plus and x minus, and we've got factors of 10 to be 5 and 2. All right, is that right? Cool. After we factored this, we make use of that property. This is greater than or equal to 0. So this is the first property, okay? Both must be of the same sign, all right? Both the terms must be of the same sign. How do we make use of the property? Well, pay attention. This is one term. This is the other term. Okay, this is like saying this term is your A and that term is your B. Okay, so it's like the product of two terms. X times 5 is one term times x minus 2 is another term. The two terms are, the product of these two terms is positive, which means you've got two cases. Case 1 would be when x plus 5 is positive and x minus 2 is also positive. Remember, how did we get this case? Because the product is positive, right? So both of them should be positive. Or, as we said, or the other case would be, case 2 would be when both those terms are negative. X plus 5 is less than or equal to 0. And that's the keyword, right? Both being of the same sign at the same time, all right? That's important. X minus 2 should be less than or equal to 0. Now we solve each of these linear inequalities, okay? So x plus 5 greater than or equal to 0 would give us x should be greater than or equal to negative 5. And that's a keyword. Keep writing that, okay? And x minus 2 greater than or equal to 0 would give us x is greater than or equal to 2. Okay? Now, this statement needs to be put on a number line, all right? And then you'll be able to understand how we are going to combine them using this word and, right? So when we put it on a number line, okay, and just let's, a rough estimate. So this is 1 and this is 2, and somewhere this is a -1, -2, -3. I need a longer line, -4, and there's a -5, all right? So that's -5, and remember it's greater than or equal to, so I'm just going to shade that. And x greater than or equal to -5 means you're talking about all values on the right-hand side, all values on the right-hand side. And x greater than or equal to 2 would be all values on the right-hand side of 2, inclusive of 2, okay? So that's the way to interpret it on a number line. We are going to use and, which means you're going to use the intersection. Now, remember when we say x is greater than or equal to -5, it means all numbers here, right? It's all the way through. So the intersection is going to be this set, okay? And is intersection. So we pick this thing because x greater than or equal to 2 automatically implies that it's going to be greater than or equal to -5. Makes sense, right? If it's greater than 2, then that number has to be, or that set of numbers should be greater than -5 anyway. So one way to illustrate is using this number line. It's easy to see, all right? So from case 1, our solution is going to be x greater than or equal to 2. But we have an or here, right? So it's x greater than or equal to 2, or let's try and solve case 2 now, all right? So we have x plus 5 is less than or equal to 0. When we solve that linear inequality, we'll get x should be less than or equal to -5. And remember that word and, okay? And implies intersection, as I said before. X minus 2 less than or equal to 0 would give us x should be less than or equal to 2. Okay, again, let's do a number line. Okay, so that if that is a 0 and 1 and 2, this is just a rough estimate to be able to visualize it, okay? I like visual technique. It's just easier to see a solution. That's -2, -3, -4, and there's a -5. Now let's mark it, okay? So we've got x should be less than or equal to -5. Less than or equal to -5 means inclusive of -5, all values on the left-hand side of -5, all right? The second one is x is less than or equal to 2. So we mark 2 and all values on the left-hand side of 2, all right? All values on the left-hand side of 2. And as you can see, the intersection then would be just this set, which means we're saying x is less than or equal to -5 combines both of this, okay? Combines both, because when a number is less than -5, it's obviously going to be less than 2. Is that right? So from case 2, we get the solution as x is less than or equal to -5. So then we combine the results from both the cases and write x must be, I'm going to write combining case 1 and case 2. What do we have? We've got from case 1, x should be greater than or equal to 2. The word is or x should be less than or equal to -5. Okay, that's the solution. All right, so remember this is the word or because it's case 1 or case 2. And we're using this word or because both of those two cases needs to be considered. And the two cases comes from that product of the two terms being positive. When the product of the two terms is positive, both those two terms must have the same sign. Let's just go over this question again. The question was given to us as 10 minus 3x is less than or equal to x squared. We rearranged it in such a way that we could see it as x squared. I don't know, it's just a traditional approach. And the idea was to then write it in a general form, meaning all the terms on one side of the inequality. The inequality here is greater than or equal to 0, and we're making use of the algebraic principle that when the product of two terms is greater than or equal to 0, both the two terms, okay, in this case, we're looking at x plus 5 as one term, x minus 2 as another term. So both those terms must be of the same sign. So we have two cases. Both x plus 5 and x minus 2 must be greater than or equal to 0, or that's the word that's separating or combining the two cases, okay? Or in case 2, x plus 5 and x minus 2 should be less than or equal to 0, okay? Now, remember a couple of things, okay? Within the case, we are combining with an and. And the two cases, can you see that even here? Within the case, we are combining with an and, which means x plus 5 and x minus 2 is less than or equal to 0. Because of that word and, we are looking at the intersection. You know, what you have to do is after you've got those two inequalities, linear inequalities now, x plus 5 greater than or equal to 0 will be just x is greater than or equal to -5. That's easy. And x minus 2 greater than or equal to 0 will give us x is greater than or equal to 2. Put it on a number line and remember that's the and. Within the case, as I said, within that one case we have and. Combining it using and is just intersection. And if you can visualize it using a number line, it is easy, all right? And combining them, you'll get x greater than or equal to 2 because, as I said, a number greater than or equal to 2 guarantees that it's going to be greater than or equal to negative 5. In the same way, when we analyze case 2, where both those terms, x plus 5 and, again it's and x minus 2 is less than or equal to 0, individually, each of those linear factors would give us x is less than or equal to negative 5 and x is less than or equal to 2. Again, the number line will tell us that the common region, the intersection, would be x less than or equal to negative 5. And that's how we combine both the cases using the word or. And then combining the two cases, we say that the solution to the inequality x squared plus 3x minus 10 is greater than or equal to 0 should be x greater than or equal to 2 or x less than or equal to negative 5. In the next video, we're going to solve a quadratic inequality that is less than 0, which means the factors, the product of the factors of the quadratic expression is going to be negative. See you in that video.